Okay, let's look at the following 4 problems. Find the area of the shaded region, and each graph represents the IQ scores of adults, and those scores are normally distributed. You can tell it's with a bell curve and has a mean of 100 and standard deviation of 15. Okay, so number 1, this shaded area is the percentage of adults with IQ scores lower than 118. If we want to do it by hand, we need to first convert that 118 into its z-score, which is 118 minus the mean 100 and divided by the standard deviation 15. Here we have 18 divided by 15, which is 1.2. After you find the z-score of 1.2, you can go to the z-score chart and find the z-score of 1.2. The corresponding area to the left of that z-score is 0.8849. So here you can say the shaded area here is 0.8849. Okay. Another way to do this problem is by using StatCrunch. You can go to StatCrunch and under Stat, find calculators, then normal, and find your mean. Your mean is 100 and your standard deviation is 15, and what we know is the score given to us is 118, and we want to find the area that is less than 118. Right? So compute. And here is the corresponding area, 0.8849. Same answer. Now let's look at number 2. So this shaded area is the percentage of adults with IQ scores higher than 91. First way is to find it by hand. So that means you have to find the z-score of 91, which is 91 minus the mean, which is 100, divided by the standard deviation 15. That gives you negative 9 over 15. That is negative 0.6. After getting the z-score, you can go to the z-score chart under negative 0.6, which is over here. You can find the value 0.2743. So, which is this area, 0.2743. Remember, in the A2 table, the z-score table, the area given to you is the area to the left of the given z-score. Okay, so to find the shaded area, you need to use 1 minus 0.2743, which is 0.7257, which is the answer to this problem. Of course, you can use StatCrunch to find the same value. Go to Stat, under Calculators, Normal, put the mean 100 and the standard deviation 15, and we're looking for the area that is greater than the value of 91, so greater than. So here you will find the same value. Now let's look at number 3. Number 3 wants to know the percentage of adults with IQ greater than 79 and less than 133. first we have to find the z-score of both values if you want to calculate this by hand. The z-score of 79 is calculated by 79 minus the mean, which is 100 divided by 15. And the z-score of 133 is 133 minus this 100 and divided by 15. Going through the calculation, you will find the z-score for 79 is negative 1.4, and the z-score for 133 here is 2.2. Okay, so first we will find the area to the left of the z-score 2.2, which is this. Right. So go to the A2 chart. So under 2.2, you can find the value 0.9861. So 0.9861. That means this area is 0.9861. To find the shaded area in the graph, you still have to find the area to the left of negative 1.4, which is this area. So again, we go to the A2 chart, find the value of negative 1.4. You can find the corresponding area to the left of the z-score is 0.0808. Alright, so this area is 0.0808. So the shaded area that we're looking for would be 0.9861 minus 0.0808, which is 0.9053. That's the shaded area. Of course, you can use StatCrunch to find this value. So go through the same process. Go to Stat, Calculators, Normal, and then you will find this normal calculator. Put your mean 100 and standard deviation 15, and instead of standard, go to between, because you want to find the area between two values. Okay, so the lower bound is 79, and the upper bound was 133. Compute. Here it gives you the area in between those two values, 0.9053. Number 4 is pretty similar to number 3, so I will only do it with the StatCrunch. So you want to find the area under the curve between the value of 112 and 124. So what you can do is go to StatCrunch, and the two values are 112 and 124. So put 112 and 124 here, and compute. Here gives you the area, which is 0.1571. Now let's look at this problem about application to real life. It says men's heights are normally distributed with mean 68.6 inches and standard deviation 2.8 inches. The U.S. Air Force requires that the pilots have heights between 64 inches and 77 inches. And A, find the percentage of men meeting the height requirement. Okay, so first let's draw a chart and understand what's going on here. So first of all, men heights are normally distributed, so you should have a bell curve. Then the mean, the number right in the middle, is 68.6. Standard deviation, I'm going to write it here, that's 2.8. Right. and I want to find the height between 64 inches, which is kind of around, let's say it's here, 64, and 77, let's say it's here, 77. And so the percentage of men meeting this requirement will be this shaded area. If you want to do this problem by hand, you will have to find the z-score of 64 and 77. So first let's find the z-score of 64, which is use 64 minus the mean 68.6 and divided by the standard deviation 2.8. So you'll get the value of negative 1. Let's round it to the nearest tenth, 64. Okay, now let's find the z-score of the other value, 77, which is 77 minus the mean 68.6 divided by the standard deviation, which is, actually this is a whole number as an answer 3. Okay, so 64, the z-score is negative 1.64, and the 77 z-score is 3. To find the area between those two z-scores, first you want to find the z-score to the left of 3, which is right here. Okay, earlier I said to the right, I mean to the left. Anyway, the z-score to the left of 3 is here, 9987. So 0.9987. 0.9987. Now let's find the area to the left of the z-score of negative 1.64, which is this area. So go to the z-score chart, negative 1.64. Okay, let me see, this is 0, 1, 2, 3, 4, right here, 0.0505. So this area is 0.0505. Okay, to find the shaded area here, you need to use 0.9987 to subtract 0.0505, which is 0.9482. And so that means the percentage of men meeting this height requirement is 94.82%. Of course, you can do this problem using StatCrunch. What you can do is go to Stat, Calculators, and Normal. And under Normal, the mean is 68.6. The standard deviation is 2.8. And here you want to find between two values. One value is 64, the lower bound, and upper bound is 77. And here you will get the probability or the percentage, 0.9484. Okay, now let's look at the B part. If the Air Force height requirements were changed to exclude only the tallest 2.5% of men and the shortest 2.5% of men, what are the new height requirements? Okay, so now let's draw a graph to understand what's going on here. Still, we have a bell curve because men's height are normally distributed. Okay, so here we want to exclude the tallest 2.5%. That means the area here is 0.025. We want to know the upper bound, right? And we also know the lower tail, the area of the lower tail is also 0.025 because that's the lowest, shortest 2.5% of men. And here will give us the lower bound of the requirement. So what you can do is go to StatCrunch. Okay, so same procedure, finding this normal calculator, stat, calculators, normal. Okay, after you get here, you put your mean, your standard deviation, and first let's find the upper bound. So let me go to the standard. Okay, I know this time we know the area, so what you have to put what's over here. That's 0.025, right? And the area, this area is above or to the right to the value you're looking for, so greater than. You can see the graph. That means this right tail, right, is 0.05. Okay, the value is 74. Let's call it 09. So this upper bound is 74.09. Okay, now find the lower bound. Similar here, still the area is 0.025, but this time you want to find the lowest 2.5%. So the x value would be less than, 0.025. Okay, so do it again. So you can tell it's giving you the left tail. The area of the tail is 0.025, and the value is 63.11. Okay, so this value is 63.11. So the new height requirements are from 63.11 to 74.09. Can we do this problem by hand? Yes, we can. You go to the A2 chart. In the A2 chart, we need to find two values. One value is this value, and one value is this value. Okay, so if this area is 2.5%, you will find in the chart the area is 0.025. If this is 0.025%, that means the area to the left of that z-score you're looking for will be 1 minus 0.025, which is 0.975. Okay, so remember these two values. We're going to find these two areas in the chart. Okay, so first one is 0.025. Okay, not looking for the z-score, but the area. So 0.025. 0.02 is here, 0.025 right here. Okay, what is the corresponding z-value? Negative 1.9, what is this? 6. Okay, so again, it's right here. The area is 0.025, and the z-score is negative 1.96. Okay, let me mark it in the problem. So first of all, I find the z-score here. It's negative 1.96. Now I want to find this z-score. Okay, so the area to the left of the z-score we're looking for is 0.975. Okay, so let's go to the positive side, 0.975. Where is it? 978, 975, right here. Positive 1.96, which makes sense because the bell curve is a symmetrical curve, right? So it's positive 1.96. This value, the z-score, is positive 1.96. So obviously these two are not the requirements, height requirements we're looking for. How do we find the height requirements? Okay, the value with z-score of 1.96 is 1.96 standard deviation higher than the mean. So it should be the mean, which is 68.6, plus 1.96 this many times of the standard deviation, which is 2.8. Let's do this calculation, which is 74.88. Well, if you round it, it would be 74.09, right? Okay, to find the lower bound of the height requirement, the z-score of that lower height requirement is negative 1.96. That means that value is 1.96 standard deviation lower than the mean, which is 68.6 minus 1.96 times 2.8. That will give you 63.112, which is the same answer as you do it using StatCrunch.